In this video, we're going to take a look at section 23.7, the first part, and taking a look at power functions. So not just polynomials that have x raised to a positive power, but power functions also have negative powers, fractional powers, decimal, etc. So just a quick review of some exponential properties. Negative powers, if you have x to the power of negative n, that's the same thing as 1 over x to the n. Or you can think about it as 1 over x to the negative 2 is the same thing as x squared. Fractional powers from a previous class, the nth root of x to the m is x to the power of m divided by n. So our roots can be written as fractional powers. So a reminder, if you have the square root of x, that can be written as x to the power of a half. Or if you have the cube root of x squared, that can be written as x to the power of 2/3. The denominator is the root and the numerator is the power. So how does this help us? That power rule that we looked at previously, where if you had a function y is equal to x to some power, the derivative was you multiply the power in the front times x to the power of n minus 1. This power property works whether your powers are positive, negative, decimals, fractions, etc. So that's going to allow us to take the derivative of any expression where we can rewrite the terms such that the terms are some constant times x to a power. So we can now take the derivative of functions with negative and radical expressions. So how do we do that? We make sure that we rewrite each of our functions in terms of some constant times x to some power. So the first function, we have y is equal to 5 over 2x cubed. The 5 and the 2 stay where they are. To get x cubed written in this format, we would take to the numerator and make it x to the negative 3. So rewriting that becomes y is equal to 5 halves x to the power of negative 3. We're taking the x cubed out of the denominator, basically putting in the numerator as x to the negative 3, and that allows us to rewrite it as a constant 5 halves times x to a power. The next works the same way. Y is equal to, we don't want x in the denominator of a fraction. To put it in the numerator, that becomes x squared. So that's going to be 3/7 the constant times x squared. Last example, to rewrite y is equal to 4 times, we have the cube root of x squared. Rewrite x as a fractional power. So that would be x to the power of 2/3. Since I've rewritten each expression in the format some constant times x to a power, now we can use the power rule to take the derivative. So the first derivative, y prime, is equal to 5 halves times the derivative, that's going to be negative 3 times x to the power of negative 3 minus 1. I'm going to put this extra step in here. The reason why, when we simplify, we're taking 5 halves times negative 3. That gives us a negative 15 halves. And then x to the power of negative 1 minus 3, or negative 3 minus 1, they're both negative, so we're going to end up with x to the negative 4. Next, we have y equals 3/7 x squared. Y prime is going to be 3/7 times the derivative of x squared, which is 2x. So y prime is equal to 3/7 times 2, that's like 2 over 1, 6/7 x. Third example, y is equal to 4 times x to the power of 2/3. Y prime is going to equal 4 times the derivative of x to the 2/3 is 2/3 times x to the power of 2/3 minus 1. 4 times 2/3 would give us 8/3. X to the power of 2/3 minus 1 is the same as 2/3 minus 3/3, so you've got to do a little fraction. 2/3 minus 3/3 is a negative 1/3, so that would be x to the negative 1/3. Okay, then you'll have some in-class practice problems. We'll do 5 through 11 together, and then I'll have the answers for 6, 8, 10, and 12. So number 5, y is equal to the square root of x. That's the same thing as x to the half. So we're going to get y is equal to 1/2 times x to the power of 1/2 minus 1, which is negative 1/2. Next example, rewrite v is equal to 3/5 times t to the power of negative 2. Now when we take the derivative, we get negative 2 multiplied by 3/5, which is negative 6/5, t to the power of negative 2 minus 1, which is negative 3. Next example, number 9. I'll put let's see, I think we can do it here. That's x to the power of a third. When I take x to the power of a third and write it in the numerator, that's going to be 3 times x to the power of negative 1/3. So when we take the derivative, we're going to end up with negative 1/3 times 3, which is negative 1, x to the power of negative third minus 1, which is negative 4/3. Last example, x times the square root of x. Rewrite as a fractional power. That's x times x to the 1/2 minus 6x to the negative 1. X times x to the negative 1/2, add the powers. 1 plus 1/2 is x to the 3/2 minus 6x to the negative 1. Now it's in a format where you can take the derivative. So y prime is going to equal 3/2 times x to the power of 3/2 minus 1, which is 1/2. Now we're going to take the derivative of the second term. Negative 1 multiplied by negative 6 is plus 6, x to the power of negative 1 minus 1, which is negative 2.